In this session, I'd like to explore building linear models in R. But before we do that, I want to show you a visualization which will kind of reinforce kind of how the linear model works. And I'm actually using a public website, which I think is, the website itself is pretty useful. And we have a couple different things. Let me zoom in on the top picture here. So what we have our data set, which is actually trying to predict height and hand size. So based on the hand size, can we predict someone's height? And here we have a series of different data points. And based on the data points, we have our linear model. Linear model you can see is a line here. And as we move the points, we can see the linear model changing. So this one point can impact the linear model that much. Now, how is the linear model changing? Kind of what's kind of it's working on? So if we go back to this picture here, there we go. So this bottom picture shows the least squares. Right, so for every point, there's a square in order to catch the model. And the model minimizes the sum of these least squares. And what we can do is we can move these points and show you how it impacts the model. So if we take this point, you can see how that's changing here. See where the square changes because it's based on the shape. So we're getting the squares, and then we're summing the squares. And that's driving the model. And as I move the point, the squares change because it's the distance, but also the model changes. So that's what creates our linear model, is this logic of trying to minimize the sum of these squares. Okay, now let's get back to R. So let's start with a simple data set. X will go from 1 to 10. Y will go from 1 to 10. We'll build a data frame, and then I'm just using the code up here, and then we'll plot that. We can use ggplot, and in fact I'll use that in a little bit, but we can just start with a simple plot. So now we want to build a model. So here's how we build the model. Just as you would expect, not too complicated. X and Y. Building a linear model, we store the results in M. We can see a summary of the results. And here's where it gets kind of interesting. So it's a perfect fit. Obviously it's a perfect fit because every time X is trying to predict Y, X is 1, Y is 1. X is 10, Y is 10. So it's always perfect. And R is saying, well, perfect is an issue in itself, actually. So you can see the adjusted R square or the R square, which kind of is how much of the model accounts for what's really going on. It's 1, so it's a perfect model. So that's what that is, and we can actually see the model by drawing a B line. There it is. So that's our perfect model. Now let's define a different data set, which maybe isn't quite so perfect. So we'll define X and Y just as a set of points. So we'll have X just be 1, 2, 3, 4, 5, and the Y's will kind of be close to accurate. And here you can take a look. So they're kind of related, but it's not perfect. Again, we can build a different model, get a summary of that. Here the R squared is 0.9. We'll always use adjusted R squared because that talks about how many variables and things like that. So as we get to add more and more variables, adjusted R squared is the more appropriate number to be looking at. But still, 90% of the model is explained by the linear model. That's very good. We can draw that model. There's that model. We can see that there's some distance, each one of these, but overall it's not so bad. I mentioned before we can actually do this in ggplot, and I guess we'll kind of bring that in as a little refresher on how to use ggplot. So in using ggplot, we'll say the data frame, we want to draw X and Y, we just want to draw points. And there's our little plot. And here what we can do is we can say, let's take a look at the linear model for those points. And you can see kind of a band of confidence, if you will. And you can see the actual linear model. So it's kind of like the AB line in the core R's plot. Let's now do a different data set. We would find a variable called W. We'll just add to the data set. Now let's take a look. So this is problematic for a linear model because it's got kind of, when x is 1, we got two different values for what we're trying to predict, W. Kind of the same thing. So that's going to be really hard for the model to be good at. Let's see what it does. So by looking at this output, what do you think the R squared is that we should be looking at? Yeah, we should be looking at the adjusted R squared, so it's 0.16. We can draw the AB line. See, the line kind of goes in between. So that's the model because it kind of averages the 2 points and says that's kind of like the minimum error you can get. We can draw the same thing in GM point with ggplot2. And again, it looks fairly similar. So now let's do something a little bit differently. Let's use another review from sampling. Remember that from, I don't know, 3 or 4 weeks ago, it seems like? So we can sample, so we're going to have numbers between 1 and 100, and we'll sample 10 of those, and we won't replace. So they'll be unique numbers. We'll do that for X and for Y. So if we're really lucky, it could be like anything. It could be a perfect prediction, it could be horrible. So let's just run that. I'm sure you're wondering what they are. So let's take a look at X as those numbers, Y as those numbers. So they're kind of all over the place. We can build a data frame, and we can plot those. Let's see what the model looks like. Not very good. As you can see, it's like it's all over the place. We can try it again, because remember, sampling, each time is going to be different. Again, not very good. The R squared is kind of like pretty much 0. So which kind of makes sense because we're just randomly doing numbers. Again, I could do the same thing. Instead of with the plot command, I can use ggplot2 and have some graphics that show a little bit more kind of intuitively. Let's go to the second part of what I want to go over now, and that is with empty cars. Let's see if we can build a model, a real model with a real data set, which you're obviously very familiar with. So the first model I'm going to build is I want to predict MPG based on the weight. Not too bad. About 75% of the data can be explained with a linear model. How about horsepower? Is that going to be better or worse? Well, that one's about 58%. So clearly, if I had to choose between weight and horsepower, weight is a much better predictor of miles per gallon than horsepower, which is kind of like how strong the engine is, I guess. How about if we combine them together? 0.81, so that's better, right? So if I look at a combination of horsepower and weight together, it's a better predictor than either attribute separately. But that's not always the case. How about if we try to look at horsepower, weight, and the number of cylinders the car has? 0.82 is the adjusted R squared. And what was the other one? So it's a little bit better, but not really much. And in fact, you can look at all the variables together, and that's a shorthand notation for show me all the variables. So predict MPG based on all the variables. That's what the dot means. And in fact, because there's so many variables, it really didn't improve, so the adjusted R squared actually goes down. As you increase the number of variables used to build a model, if you're not increasing kind of accuracy, the adjusted R squared will go down. So let's take a look and maybe stick with this one. So that one's as good as most of the others, or roughly as good. So we'll stick with, we're going to predict MPG from the weight and the cylinders. So we can use the model to predict a new car, what do we think its MPG will be. So in order to get a reasonable range for the weight, here we go. So the minimum weight is 1.5, that's probably tons, and 5.4, so somewhere in between. So we'll say the number of cylinders equals 4, and the weight equals 2.8, and we'll create a new data frame for that. And then we can predict. So we'll use the model that we created up here. We're going to use our data set, and we say, tell us what you predict. So it predicts the MPG will be 24. Now if we went back and made the weight less, so it's a lighter car, let's have it predicted again. 27, see? Because as the weight goes down, the MPG is going to go up. That's kind of how that works. Now, let's see, what do we want to do here? Well, I guess we can take a look at the summary of our model and store that in a variable. So rather than just outputting the summary, which we could do, there's all the standard information. But rather than kind of just dumping all that out, maybe I'm going to show you how to kind of create an intuitive way just to take a look at the results. So the probability that this model is accurate with kind of a 95% accurate level is in this data set, and it's kind of right over here. So we want to get that number out. So we say p-values are those. And the adjusted R squared is that. So if we want to take a look at the adjusted R squared, we can always just use that. So rather than outputting things and then just looking at raw output as a full list that we can here, I mean, this is fine. But sometimes we want to store that in a program, in an R program, and then keep going. So you can actually access the model as an object and access the information in it. In fact, we could take a look at the structure of sum.model. And here we go. So here's the actual structure. It's got a lot of information in it. The terms, it's everything that was built, but I can kind of take a look at how it was built. If I go down here, I can take a look at the data frame that was built in. I can take a look at the adjusted R squared and the R squared. So some of the key things I can take a look at. There's other things in here that we can kind of take a look at if you're curious in terms of, for example, the intercept and things like that. But that's, for now, the key items I thought I would show. But maybe one last reminder of ggplot is let's build a scatter plot. So we can use ggplot. We're going to use the empty cars data set. We're going to do horsepower and weight, and we're going to show that as MPG. So we're kind of predicting MPG based on the weight and the horsepower. There we go. Let's take a look at G. So here's a scatter chart where MPG is double encoded, both in terms of color and the size of the bubble. So with less MPG, with less horsepower you get more MPG, and with less weight you get more MPG. But you have an outlier. So here's a car that weighs a lot, fair amount of horsepower, and still a reasonable amount of MPG. Now we can do our smooth method here that we've seen before. So this would be the linear model for all the different data sets, the data points. And we can see it does a pretty good job. So I think we'll stop there, having looked at the mtcars data set and building linear models, and using both the ggplot to look at some of the variables, as well as just the simple built-in R commands.